Okay, so let's continue the system design, and today I am going to talk on one of the very basics and key capability of system designing. And whenever we are designing system, and generally if your system is for big organizations and they have a large volumes of data, and they required kind of optimal performance even the large data set. So one of the key features customer expecting, if the user loads are so high, so increase, and even our systems are give the optimal performance, even our data size are so heavy, so scale. Okay, maybe our whatever the database we are storing some, they are storing huge data sets. So those things, how we are ensuring while system designing, our system can handle the increased load on the large data set, system behave as expected, and performance cannot degrade. So in this scenario, one of the key capability of system design, your system should be scalable. Okay, your system should be scalable. So we talk about the scalability. That means scalability means if the number of requests or user loads are going to increase, even our system is give the response and the performance are not going to degrade. Okay, so this capability, our system should be known as a scalable. So we are going to talk what the meaning of scalability and how we as a system designer ensure that our whatever the system we are designing, that's are capable to handle the user traffic load or large data set, and without compromising your performance. And even I'm not expecting, hey, if the user request is going to increase, our system is not responding, our system say, hey, I'm not available, something I don't want. Our system should be always response and performance as previously. So this concept, this kind of systems we can easily achieve through scalability. So we are going to talk today scalability, what kind of scalability, what are the key concepts of the scalability, what are the best practices, and what are the key techniques through which we can easily maintain scalability in my systems, and what are the key use cases and the softwares that's available in the market which help us to easily make designs our system more scalable. So let's understand the meaning of scalability. Scalability refers the ability of a system to handle increased load, traffic, and demand. So whatever I'm building my systems, if the user request is going to increase so large number, or even the load of data, we are going to load huge data set. In this scenario, without compromising the performance, reliability, and user experience, our system can handle those cases. So we don't want our system user experience feel, hey, now system is performing very slow, and it's your system engineer say, hey, because in your system you have to managing the huge large data set. So even your data is large, even your user traffic is going to increase. In those scenario, our system should be handled proper, response properly given. This is the meaning of scalability. Means refer ability of the system to handle increased load, traffic, or demand without compromising the performance, reliability, and user experience. User does not affect use my system as previously they are using. Even one user don't know. Let's say I am a one user, am I using my application, so I'm thinking I'm only one user, but system know at this time thousands of other requests also processed by my system. So you cannot give the answer, hey, currently your system is processing 1000 requests, due to that you are getting the slower performance. Maybe your request at this time cannot entertain. Okay, this kind of bad user experience. So from user perspective, our system is behave as daily basis, as generally how they are expecting, how they are using the systems. From system perspective, is it clear that you are maintaining thousands requests, but for individual customer is the only one. They are accessing your system and they are customer expectation. I am getting my response as expected. So we design a system that can behave as expected in the high load, high traffic situation. Hope so. These things, whenever we are designing the such systems and we are ensuring that our system is so highly scalable, so this is possible after some kind of a you can say conditions. The scalable system can adopt changing condition as increase in user data or transaction by adding or modifying resources, hardware, software, infrastructure to maintain or improve its performance. So what this say, whatever the top level scalability concept, this can easily maintain or achieve just providing additional resources, or maybe hardware, maybe software, maybe infrastructure. So as the user request is going to increase, we can provide the more and more hardware, more and more software, or more and more infrastructure, so that user, our system in a position they can handle those high loads and even without compromising its performance. So we are going to understand what are the way where we as a system engineer are ensuring that we can provide additional hardware, additional software, additional infrastructure to my systems at a runtime. Sometime higher hardware, software required, sometime maybe low. So depend upon the use case. Now our system is heavily used. At that time, we are going to increase our servers. If our server is used by the normal rate, might be 1 or 2 server is capable to handling. So scalability means our system should be handle large request, concurrent request, high load, and this is achieved just by providing additional, okay, or changing the current infrastructure. Whatever the system deployed, what number of server, what number of hardware, what number of infrastructure, that might be capable for managing thousands requests. But if more than 1000 requests come, might be I can increase my software, increase my hardware, increase my instances of the software. So these things, through this way we can achieve scalability. So how we can add or remove? What are the way to increase our resources? Okay, so these are the two kind of terminology we are using. So scaling, the process of increasing the capacity of the system to handle large loads or demand. So this achieve to handling large request or demand only to increasing the capacity of my system. What do you mean capacity of system? Generally, our software systems are built on the some hardware, some software, or some other infrastructure tools. So we have to increase them. So generally, there are two ways. There are two kind of, you can say, scaling. One is the vertical scaling, another is the horizontal scaling. horizontal scaling. So sometime you can say scaling up and sometime scaling down. So maybe you are going to up means increasing the number of resources, and sometime, hey, now maybe today there are some festival season going on and large number of requests come on my system, so I can go increase my hardware software infrastructure. And next couple of days, maybe after 1 year or 2 days, now our system behave in normal rate, normal requests come, so again we are just downgrade, again down, again decrease my the extra resources. So on the demand basis, sometime we are going to increase our capacity, sometime might be if there is no high demand we can decrease our capacity. So scaling meaning we can increase our capacity or we can decrease our capacity in the case of the customer demand, user requests according to the system load. So both scaling, not just to increasing, scaling means maybe plus or minus. So there are two kind of scaling. One is the vertical and one is the horizontal. Sometimes we can say scaling up and scaling out. We are going to talk what do you mean by how we increase the vertically or how we can decrease the vertically. How horizontally we can increase the system and decrease the system. Okay, so let's talk about these two. So let's talk first vertical. Vertical scaling, that means whatever the one server have which are currently handling the user request, it's good. So vertical scaling say just upgrade your server capacity like a CPU, RAM, hard disk. Generally in my server, these are the key components. One is your CPU, one is your RAM, one is the hard disk. So if our request is currently handled by maybe only the 2 CPU, maybe I can increase the 4 CPU. Maybe we can increase the 8 CPU core, or maybe our RAM is the 8 GB. We can increase to the 16 GB, or we can increase to 32 GB, or 64 GB, or 512 GB. Depend how much our user system are load receiving. So this is known as your vertical scaling. This whatever the server we have currently, we are going to make one higher capacity server. Increase the RAM, increase the OS, increase the hard disk, so that our system can handle more and more requests. Okay, so vertical means whatever the system you have, the part of those system you are going to make a superior, maybe powerful system you are going to make. So what are the use case scenario where you are going to make your vertical scaling? So when a system experiences sudden short-term spike in the traffic and the existing infrastructure can be upgraded quickly to handle those increase. So this is somehow the short-term period for the couple of days or week, the particular understanding in this time frame our system is can be expected receiving the huge number of requests, traffic going to increase. In those case, what you did, you just upgrade your CPU, upgrade your RAM, upgrade your hardware, so that the system can handle the scenario. So these kind of scaling is very simple, easy to implement, and also minimize downtime. And in this case, whenever you doing anything, they have some benefit or they have some advantage. So what are the benefit? Is easy to implement. What are the disadvantage, drawback? The drawback is the limited by the hardware capacity and expensive. Means whenever you are increasing your RAM, memory, something, first things, after some extent, you cannot increase the hardware, RAM, CPU, right? And so after some extent, some level you can increase, that's okay. But still our system is increasing more and more traffic. After that, you cannot going to increase the vertical scale, because you cannot increase more CPU, because thus where you are plotting CPU in your motherboard have a limited slot where you can put, and similarly RAMs, and also we have some buses. How our CPU, what number of byte data read, what the bus size. So there are some hardware challenges in the computer system. So some extent you can increase. Vertical scaling is good, but after some level, when you achieve, after that you cannot increase our CPU or increase our RAM or hard disk. So this is the drawback. And also one thing, whenever you are increasing this capacity, your cost of such powerful machine is very, very expensive. So vertical scaling is become a very expensive, because you are going to buy such machine, such motherboard that support high number of CPU, RAM, buses. That's become very, very costly and expensive. But for the smaller low traffic, some short period, it's good. It's very easy to implement. Just increase the RAM, increase the memory, and your system can work perfectly. That's good. This is known as your vertical scaling. Vertical means ki whatever your server has, you are make more powerful, more powerful, more powerful. Increasing RAM, increasing memory, increase this. Second kind of scaling known as horizontal scaling. This means adding more servers to the cluster using the load balancer to distribute your traffic and load. So here say whatever one server, these are handling the requests. Okay, good. So instead of going to increase the hardware, I am going to increase the number of servers. Server 1, server 2, server 3. Similar kind of facility, and we can increase the multiple servers, and we use the load balancer, and users request come on our load balancer API gateway. They are distributing request to different server. So now if one server can handle the 1000 requests, now this is also can handle the 1000 requests, this is also can handle the 1000 requests, this is also can handle the 1000 report. If you need more, you can just increase more server, you can increase more server. So whatever the normal server previously you are using, just adding more in your cluster, and all the requests is routed to the different server depend upon the your load balancer algorithm and policy. So horizontal means just you are adding more server. You not need to buy so highly so powerful and so costly system as normal server of whatever the currently using. Just use them increment, just add more server. So horizontal scaling means adding more servers into the cluster. The use cases: system experience, and whenever you see long-term growth in the traffics and existing infrastructure can be replicated to handle the increase. Just whatever the existing server will make a new copy, make a new, and these are your benefits: cost effectiveness and flexible and fault tolerant, as well as if some servers, maybe you have created multiple server, okay, added, and whatever your API gateway and load balancer routing the road. Let's keep this server somehow crash down. Our load balancer no, okay, this is not responding. Let's see, I route all the call to the different server. Or we can add the more server. So easily you can add more server. If some fault happen, you can discard it and replace the new one. Okay, and what the drawback? So this is the very complex setup and can increase the manageability. And so whatever you are increasing number of server, it's easy to add, but we need some extra work to manage apply the load balancer here, ensuring every system is working fine. You have to monitor every system and check every system health, it's working fine. Is any kind of a memory issue, any kind of over outage, you need to add more, or you notice there is no traffic coming, you have to just pull out those resources. So extra, this is a kind of complex kind of a deployment become, and this will require extra monitoring, analyzing your infrastructure. So this need one extra overhead. You have to monitor your infrastructure, check health of every machine. If any machine is healthy or not healthy, over healthy, you have to take decision and replace them or add new one. And lots of other challenges also. There are some benefits. This is a very cost effective, very flexible, support fault tolerant, and you can handle, now your system is handled as request more come, because simply if more requests come on the, you can add more server, more requests coming, add more server, number of server are going to increase, and you are saying, hey, now my system is so scalable, whatever the number of load customer user traffic increase, I can handle, I can manage, because we have to just increasing more server, and we can get the benefits. So both have some kind of advantage and drawback, benefits and drawback. So if you look from the customer perspective, if maybe you are designing system, maybe vertical scaling, horizontal scaling, for system perspective, system always use the same machine, this scaling part is just about your background changes. Here your older machine you are replaced with a very bigger machine, but here in horizontal you are adding 1 server, 2 server, 3 server, 4 server, 5th server, whatever the number, you can just, from user perspective, they just accessing whatever the application previously they accessing. There is no change. From user point of view, there is no change. Scaling is just our background activities for ensuring our system always ready and response. So from user perspective, for customer perspective, they doesn't matter you are using your system is scalable, or you are doing vertical scaling or horizontal scaling, how to managing, that's the infrastructure issue. But internally, as we say, system design engineer, we should aware, hey, if something user traffic increase, we have to approach. We have to maybe make our existing server as a very powerful super server, or you can just add more server. So in this way, we can achieve our scalability. Maybe scalability means if your systems is going to expecting more and more user traffic come on your systems, you have to apply the increasing your capacity of the server. That means maybe vertical increasing or horizontal scaling. And once you, after some time, you visualize our system have a normal load, you have to decrease the capacity. Just so maybe use the older machine or remove some older server or extra server. That might be 2 or 3 or 4 or 10 server is sufficient to handle this load. So nowadays you can say for the larger user base, large data set, horizontal scaling is more preferable choice nowadays. They have a cost effectively, and they are ensuring the number of traffic going to, because if your application you are building that can available across the geolocation, across the world, you don't know the number of user traffic come on my load. So you have to go horizontal scaling, the preferable choice, because they have a very normal servers you are going to use, not very costly, not very powerful machines. Any ordinary servers you can use, just scale them. It's very fine. And nowadays, due to the cloud environment, due to the containerizations, due to the virtual machine concept, Docker, they are we can build small lots of server or node they can easily manage, they can easily scale, they can everything nowadays DevOps provide to us. So you can say if you are designing system that's expecting large data set, huge user traffics, go design your system must be scalable and go with the horizontal scaling. If you have a, occasionally sometimes some limited traffic, user traffic increase, then you can go with the vertical scaling. So let's talk types of you can say scaling. Whenever you are going to talk the systems while building the system, so while building system, couple of places you are going to increase the or scale your system. One about the load scaling, one about the data scaling, one about the geographical scaling, one about the temporal scaling. Sometime you want to scale our data base, our data set, somewhere your request coming load, somewhere your geographical, you maybe increase the for different geographical locations you want to scale. So nature of the systems, you visualize which parts our data is going to increase or user traffic is going to increase, or where accordingly you have to apply a scaling algorithms. So if you talk about this load scaling, load means, as Visual mentioned, our increased user traffic, that means request. Our systems now are receiving high concurrent, higher number of requests. That is known as a user traffic, increase in user traffics. Maybe user customers are sending multiple requests, or maybe another machines, another software are sending a request. Finally, our servers, our systems receive the traffic, means request is higher. For example, whenever we are building any web server, so our web servers should be handle large number of concurrent user. Concurrent user, that means ki whatever application I'm designing, this application, let's say at the same time, maybe thousands users are accessing my application. Our system should be response. Next time, concurrent at the same time, multiple people are accessing this. That means same time, this user accessing, this time this user accessing, same time multiple users, same time maybe 1,000, maybe 500, I don't know. So if in your systems, your web applications, if your concurrent users traffic is going to increase, then you are applied to the load scaling. You are going to increase your request level, web server level, you have to apply the scaling. If you talk about the data scaling, that means to handle increase the data storage and processing requirement. That means whatever the server you have, good part, whatever the server, they are receiving the request and they are going to store data. They are receiving request, but the data they request receiving is the very large. They are going to increase. Maybe here is the full, our one database full, then we need another database. This database full, another database. So might be sometime we need a data storage scaling. So maybe database, maybe file system, maybe processing. So sometime you observe, hey, now our system is getting more load on data side, processing side. Then you have to think, I am going to scale my database to store and process large amount of user generated data. So nature and the flow, which part of my system, traffic increase, load increase, data storage increase, accordingly we have to choose which portion of my system I am going to scale. Scalability concept is same, maybe horizontally, maybe vertically, but which portion, because we are designing the system have multiple components. One is your user request handling, one is your data storage, one is processing, one is integration, right? So you have to think which modules, which component required scaling. Similarly, maybe geographic scaling, that means ki might be your application support user in a different geographical location. You are building application, that application are maybe accessed by the across the different maybe one north side, south side or different continent size, different continent, so you have to support. Our system should be scaled to support user in the multiple region and its own language and cultural preferences. Your system should be like some country, some continent, by the different language, different preferences, or some have a different huge traffic in a specific language or a specific region. The region wise, maybe some region, maybe European parts, or maybe African parts, or South American, North America side, different geographical location. Might be some geolocation you have to scale, some geolocation might be not required. Let's say might be Indian side, lots of user coming traffic, maybe China side, lots of traffic coming, so might be you have to speak those region only. You have to scale those regions where you are receiving the higher number of user requests. Might be some maybe African, maybe Australian, maybe side, maybe North American side, yeah, South American side, you are receiving maybe lower requests due to the populations. So due to that, some where as region wise you have to also need to scale your system. Okay. Similarly, sometime temporal means just scaling a handle to traffic or load over the just seasonal or some function or some festival. You know, okay, some New Year festival come, then the lots of people are going to generate messages or send something. So maybe for a couple of days, I am going to increase my traffic, and after that whole year might be we are not getting more traffic. So sometime we just temporarily we can increase, or sometime notice our all the e-commerce websites or company offer some special offers, special sale offer. Maybe on the month of July for 1 week we are going to free some for some off coupons going on. So lots of people are try to access this these day your system or platform. So in this case you have to also think we can scale for the some period of time, maybe for 1 day, 1 week, 2 days, 1 month, depend upon the you are offering some good services. So maybe basically all the e-commerce platform to handle increased load traffic during the holiday season, maybe some festival season going on, holiday season going on, some national international activities going on, some common activities, games are some going on, some happy new year something activity going on. So for those scenario our systems should be temporarily you can increase the load, our system should be handled. If your season or holidays festival activities going off, we can again decrease. So scaling means both options. Our system should be automatically maybe increase depend upon the your user role, or automatically decrease depend upon the users load or traffics. So nature of the you can say systems, you have to think which part, which area, just one module, maybe server level, database level, region wise, temporarily you are going to apply this scaling. And sometime we also why not the words like elastic scaling, multi-tenancy scaling, and microservice level scaling. So sometime we are going to talk later microservice. Microservice is the one kind of a service which are designed for serve specific purpose, and this maybe service level not only the request handling, might be internally your one service are handling requests, might be they are interactive with the database. So might be this service which are handling requests that might also require multiple instances. So might be microservice level based or multi-tenancy based or maybe elastic. So these are the some scenario situation where you have to also think we can apply scaling. So what do you mean by elastic scaling? So automatically scaling resources up and down in the response to the changing demand. So this is the nowadays very almost all the good big cloud provider offering auto scaling concept. That means our systems, whatever the user request come, they know what the system loads coming, accordingly internally automatically they can increase our services, increase our database, increase our server microservice, right, instances. And if our load is very low, automatically they scale down. So you can say resources up and down both are done automatically, that is known as elastic scaling. So maybe you talk about Amazon or Google, they are the microservices, all the public big cloud providers offering such this feature. Means ki as a human you just define the threshold. Hey, if my system 10%, this number of server I required, 20% increase, this kind of server number of server required. If 80% increase our traffic, you can go to the this kind of server. So you have to just configure, hey, I want our scaling should be automatically. So nowadays you can just provide the whatever the right choice for your cloud provider. They support auto scaling feature, dynamically add or remove server based on the traffic. So whatever the traffic come in your system, they calculate the algorithm, find out the traffic uses, and accordingly they can maybe increase the number of server, or maybe decrease the server. The auto scaling automatically it happen, maybe addition of resources or removal of server from your system. So this is considered as a elastic scaling. Similarly, you talk about the multi-tenancy scaling. What do you mean by multiple isolation instances of server system to handle different customers or organizations? What do you mean? So here multi-tenancy application nowadays many organizations, due to the cloud infrastructures, nowadays I am just building one applications. These applications all generally product based companies are using. Hey, I am building this software for ABC company. The ABC's company are using this software. Okay, similar kind of functionality, everything, and the same functionality I can sell to XYZ company. So I am going to say, hey, this is the application is multi-tenant application. Means ki one company are accessing, just look like, hey, this software is built for myself. Similarly, XYZ company is accessing the same application. They are feeling, hey, this is designed for myself. So different organizations, different customers are using the same applications. You just build one time and sell different customer. Nowadays, lots of ERP system, lots of financial system, lots of security application systems or products generally build one, and that's are sold by the different customer, different organization. So here different organizations known as a one tenant, right? The tenant base. Sometimes you notice ki currently this application are accessed by the four organizations. So they behave very fine. But sometimes you notice our system performance going to down. So maybe you can say I am going to deploy one instance just for this company and one instance for this company, and two are sufficient to handle the one application. So might be scenario where one instance of your application handling the two organizations and another two more instances you run that kind for separate XYZ company and for different company. So sometimes you are going to scale our application depend upon your organization for which you have built the software. Sometimes multi-tenant application as well as. So depend upon the use cases. Okay. So generally this kind of application you can say scale software as a services, a SaaS application. That is generally whatever building SaaS application, they support the multiple tenants. Okay, each tenant its own configuration and data. Okay, so you can say whatever I build application for one customer for a specific tenant, I configure different way, and same application for different tenant I configure different way. Might be there with 2-3 feature, yeah, 2-4 feature. So generally multi-tenant applications are built such way this application can be customized according to each organization. To each organization, let's say I am working a company. If I am accessing this system, so I feel this complete whole system is built for me. My company logo come and basic functionality as per the my rules and regulation. This system behave. Same system, same instance are used by another company. If his employee going to log in, he feel, hey, this is just run for myself, for me. They are designed for me, because they are configurable. They are multi-tenant applications are more highly configurable, and you can configure depend upon the each customer or each organization needs. Such kind of application you can also scale. Maybe scale one application for individual customer, one application for multi-tenant. Sometime whenever any requests come, generally come, hey, our load balancer receiving the load and forward, hey, this is the service they can handle, and this service are going to store data in the database. That's true. So might be if you notice this service are very heavy, lots of requests come, then you can again start another instance of the same microservice. Now loads are distributed in the two. If still they are receiving the more number of requests, again new instance of the same microservice we can instead. The service here that can actually the service your provide the business logics. Might be 3 microservices or 4 microservices of same microservice have multiple instances. Okay, so generally scaling a specific microservice responsible to handling payment with the e-commerce platform. So whenever you are building any system, and might be for UI handling another microservice, for product view or catalog another microservice, for payment another microservice, for displaying all the items another microservice. So for different small use cases, small function, generally we will build the different microservice. You notice some festival season going on, so lots of user viewing my product, searching my product, maybe ordering. So might be this required the highest number of scaling. Maybe payment system is everyone not going to do payment, not going to make an order. So might be payment system is required the less number of server scalability. They may be user searching microservice required the high number of servers. So depend upon your use case, each microservices are going to scale up and scale down automatically depend upon your cloud service provider. Okay, so these coupling scalability are you can say generally implemented using some design principles. So we should aware whenever we are designing such systems, so we should know the basic principle behind this scalability concept and thought. We should aware how this happened, how our cloud provider automatically up server, multiple server up, automatically down the server. If our system is not developed such a way, might be we are facing couple of problem to scaling up, scaling down. So while designing system, we have to keep in mind we are designing system that can be scalable, then our system should follow some scalability principle. Okay, like we discuss couple of I'm not going to discuss lots of scalability design principle, but I'm going to talk couple of them. So you should aware why while system designing, why we talk this hardware resources up down. This is not a responsibility of the software engineer need, because you know the my code is going to run on the different server. So how system going to request go to entertain with the different server? So if our code, our application is not designed in such a way that can be run on the different instances, it's very hard for the cloud provider to automatically scale your systems. So due to that, while the system designing, we should aware, because you are writing code, you are implementing code that in future can run the multiple instance, multiple server, multiple geographical locations, right? So you are written such code, follow some principle or not. So first and most basics is the, if you know whatever is system designing, okay, that's our scalable system. So you must ensure that whatever the your use cases, like any e-commerce application, search portal product and list view all the product, and similarly list all the product, maybe make a card, order the payment, track the shipment, delivery, all kind of functions on a one particular system. Okay, if you design such a system, is just only one microservice, one server, one business, one code, one component. So it's very hard to scale. If you are scaling, you are losing lots of cost. Might be this customer search product catalog is high request. Maybe this is required the 10 instances to run. Might be payment or tracking required only 2 instances, or 1 instance is sufficient to payment. But if you are building everything in a one system, they are going to scale wholly. Wholly you can make a 2 copy or 10 copy, 100 copy. Notice all the unnecessary, these activities might be not required such high level of scaling. So if you build system, design system for a specific purpose, these are separate microservice, these are separate microservice, these are separate microservice, these are separate microservice. Each logical function should be in a separate microservice. They are running in a different server. If a specific payment gateway required the higher number of scale, they can increase. Maybe only update some profile detail. Might be required not more instance than search microservice. Search microservice required the 10 instances. Might be update product required only 1 microservice. So if you are designing a system that are highly functional oriented, use case oriented, that's good. So this principle say, break down your system into the smaller independent component to simplify the scalability. So this is the key feature of scalability. You are building your system for very small use case and independent module. Two or three modules are as independent. There is no dependency. That means one module can run on another server, one module can run on another server. So please keep in mind, whenever you are designing systems, just break down your requirement into the smaller use case wise, specific function wise, and independent component. That help us to achieve scalability very cost effective manner. Similarly, now you have decided I have a breakdown my system into multiple small services. That's great. So what kind of a dependency between this? Avoid too high dependency, tight coupling between this software. The relationship between these components is loose, not make too tight coupling. If tight coupling, also we are feeling problem with the scalability. Your system is very loose couple, they can easily scale, they can easily run on the different instance of the server. So loose your system, the component independent module should be as minimum coupling should be. And similarly, whatever the component you designs, that make as possible independent, so that the minimal reliance or dependency with that. If system is insufficient to work independently, that is a very good choice. If all the components are work very independently without any kind of a hard coupling, or some kind of a message exchange required, you can do. So that's also help us, our scalability can achieve easily and cost effective. And one more things, whenever you are designing the services, and if possible your service is the stateless, they are not storing some kind of a transactional, some kind of session information. What happened, let's this is a 2 instance going on, and one request come here, they are doing something, and some specific session information you are store here, and next request maybe of the same customers are go to the here. In this instance, notice this is the not this data is not replicated here, not available, you can say, hey, this is the something unwanted happened. So designs your microservices, design your system as possible stateless, because generally the protocol, the way is your requests generally come from your HTTP. HTTP protocol is also stateless. They are not maintaining any kind of state conversation between the request and response. So if you are designing systems, avoid to sharing some kind of states. If stateless is very preferable choice. If you want to require some kind of a shared, think carefully. I can design system to avoid share between the multiple components. That's simplify our scalability concept. If you are building a system, that system, each component are very stateless, some minimum level of sharing required, it's okay. Such system easily scalable. That's, you can say, that means you are designing system that can very scalable. And one, not the last, but this is the asynchronous processing. If possible, use the asynchronous processing to handle request and response and reducing the load on individual components. Let's say the component 1, component 2, component 3. If they are giving the request and this request processing take couple of times, don't tell the customer to wait until your request is not done, right? It required 2 minutes. So why your users are waiting for 2 minutes here? Just quickly respond them, hey, I receive your request and I'll further processing and update you. Just go back. Just respond them, hey, I done for you. Your request is recorded. And you do asynchronous processing. Once done, then you inform the customer, hey, your processing is done. You can check the status. Let's say customer next time come here, hey, what is the status? Hey, it is done or pending and in progress. So if possible, you are try to do asynchronous processing. Asynchronous processing help us to user request and response very quickly. Just request, initiated the processing and response back, hey, your request is received. Now our system is free, ready to receive another request, ready to receive another request. If your systems are receiving one request and taking couple of second, a minute to response, at that times your system accessibility are reduced. If your system quickly responds, now your system is free to accept another request. Quickly responds, free to receive another request. So asynchronous programming help us to increase the number of requests. Every request received by server quickly responds. Now your server is free to take another request. So try to implement your business logics, if possible, to do some kind of long processing, like payment processing, like interest calculation, something credit check, something where you think some time will take. Do the asynchronous processing, and whenever any request come on a system, okay, quickly respond them, and in parallel just start another threading, another model, they are doing processing, and once done they will update you. So somehow asynchronous processing or programming help us to quickly respond every and each request. If you design a system, that's very help us to meet scalability concept. Okay, so these are the some couple of you can say design principle which we have to keep in mind while designing systems. Let's talk some kind of techniques. While implementing scalability, we have to choose some techniques like caching, loose coupling, CDN, load balancing, data sharding, and message queue. These are the some kind of techniques you have to implement in your system, so your system is highly scalable. What this technique means? One of the key principle about the cache. Cache means let's you design your application. you receive the request, hey, receive request, you go to the call to the database, read the data, and again response them, you do couple of processing, formatting them, and back responding them. Okay, so notice next time again request come, again you go to do backend DB call, again response back, again do processing and return backs. So this will take some time, millisecond time to process the record, because your database call maybe networks bandwidth, database call require the more times to process this query run due to the lots of problem. So is it possible if first time I get data, a same request again come, why not we cache store data temporarily here? Somehow we have a concept to cache data. So first your request come and look your cache, is this data exist, and response directly. If no data found in the cache, then you can go get data from database and again process and update in your cache. Once cache updated, then response. So next times you are save this kind of a time to calling database, getting, now you already processed and saved data. So you can say store frequently access data in the memory to reduce load on the database and other subsystem. So this help us to our system handle increased traffic, because our server is very release frequently response data. Now it's ready to read more and more requests. So our systems can handle more requests and quickly response, right? So here caching is one of the key kind of a performance parameter. So whenever you are increasing scalability, your system meet the performance criteria, caching is help lots meet the customer performance expectation. Similarly, you have to also while designing, you can use this concept like a CDN, content delivery networks. What it means distributed content across the multiple geographical locations to reduce the latency and provide the performance. Here notice whenever you are building any UI application, web application, this application can be accessed by across the geographical locations. Okay, and if let's your application have some kind of UI, some images, some colors, some photographs are loading, so everything are stored in one centralized data. So due to the latency, maybe particular one locations where every information like all the HTML file, JavaScript file, photographs, everything you are stored, that takes some time. Every request, every customer you have to load on the browser. So this due to the latency, maybe this is the Northern American side, this is South American side, this is African side, this is the Australian side, maybe this is the Asia, this is the Europe, different region your application can access. So this network, content delivery network, ensure that across the different regions, this whatever the master data are replicated and replicated. Now every request get his photographs, image, HTML from the local server. They can feel user experiences better. Quickly you are loading your image, photographs, HTML pages, JavaScript codes. Okay, so this is a such network. Whenever you are designing system, you have to ensure that all the static contents we can use the CDN, so that across the multiple regions your static contents are easily fast without latency. With a low latency, easily your application can get data from the nearest location. So whatever the region your server going to access by the customer, whatever the nearest CDN server offer you to the all the static content like HTML, like JavaScript, like photographs, like images. So nowadays, if you are designing such systems, please keep in mind you have to implement CDN, use the CDN technique to improve the performance and reduce the latency, so that when our application going to scale, you meet your performance and user experience as good as previously they are using. So CDN is also one of the good techniques to improve the customer performance. Similarly, you have to design your system with the load balancing. Reason is that load balancing is the where all the requests you are coming, okay, and now depend upon the number of server you started. Number of server is started. Accordingly, some loads are going to this server, some percentage go here, some percentage go here, some percentage go here. So you have to use the kind of API gateway and load balancing that distribute our traffic across the multiple server to improve the responsiveness and reduce the load on the individual server. So instead of every request go to the specific server, we can distribute the request to the multiple server so that our each server have a enough space to quickly respond. If